Hi, this is a Pure 1 crash course. It covers all the different types of questions that come in the Pure 1 exam. Make sure to go through the whole video to give yourself a chance at getting your dream results. Enjoy. Let's get started. Express 2x squared plus 12x plus 11 in the form 2x plus a squared plus b, where a and b are constants. Okay, so they want us to complete the square. So we have 2x squared plus 12x plus 11. What we're going to do is we're going to factor out a 2 in the first two terms. So that becomes x squared plus 6x plus 11 outside the bracket. And now we're going to complete the square for whatever is inside the bracket. So you're going to open a square bracket here, and now we're completing the square. So that's x plus divide 6 by 2. That's 3 squared minus 9. And then you've got your plus 11. And now let's expand the square bracket over here by multiplying through by 2. So that becomes 2x plus 3 squared, 2 times negative 9. That's negative 18 plus 11. And so you end up with 2x plus 3 squared minus 18 plus 11. That is minus 7. And this would be your final answer. A line with equation y equals mx minus 6 is a tangent to the curve with equation y equals x squared minus 4x plus 3. Find the possible values of the constant m and the corresponding coordinates of the points at which the line touches the curve. Okay, so we're given that a line with equation y equals mx minus c, y equals mx minus c, and then we're told that this is tangent. So when we talk of something being tangent, I'm just going to draw. We've got a quadratic curve here, and then we have a line being tangent to that curve. It means that that line will only touch the curve at one particular point. And what does this tell us about the discriminant when we only have one point of intersection? It tells us that b squared minus 4ac is equal to 0. In other words, the discriminant only has one real root. Okay, and this is tangent to the curve y equals x squared minus 4x plus 3. So y equals x squared minus 4x plus 3. So let's start by equating the two equations together. Mx minus 6 is equal to x squared minus 4x plus 3. Let's put everything on one side. X squared minus 4x, move this to the right hand side, minus mx plus 3, move this to the right hand side, that's plus 6, and this is all equal to 0. So this becomes x squared plus, we're going to factor out an x here, so that's negative 4, negative m, then you've got x. 3 plus 6, that's plus 9, is equal to 0. Now we can use the discriminant b squared minus 4ac is equal to 0. But first let's identify a, b, and c. So a is the coefficient of x squared, which is 1. And then b is what we have in this bracket over here. So that's negative 4, negative m. And then finally c is this 9 over here. C is equal to 9. And now we can substitute into the discriminant. So b squared, that's negative 4 negative m squared minus 4 times a, which is 1, times c, which is 9, and this is all equal to 0. Let's expand our quadratic here. So that becomes m squared plus 8m plus 16 minus 4 times 1 times 9, which gives us 36, and this is equal to 0. So this is m squared plus 8m minus 20, and this is equal to 0. Now we have a quadratic equation. Let's see if we can solve this by factorization. Put m, and we're looking for factors of 20 or negative 20, that will add up to 8. So that's plus 10 and minus 2, because 10 times negative 2 gives us negative 20, and 10 minus 2 gives us 8. Equate each bracket to 0, so that's m minus 2 is equal to 0, and then m plus 10 is equal to 0, so that simplifies to m is equal to 2, and m is equal to negative 10. Okay, so we found the possible values of m. Now the question also wants us to find the coordinates of the points of intersection, or the points at which the line touches the curve. So to do that, we would basically have to solve these two equations simultaneously. And we know that we created an equation that combined the both of them, which is this equation over here. Let me write it on the side so that it's clearer. That's x squared plus negative 4 negative mx plus 9 is equal to 0. So this is the equation that will give us the coordinates of the points at which the line touches the curve. But now that we have the values of m, we can simply substitute those values and then solve the resulting quadratic and get our coordinates. So in this case, we had two values for m, so we'll start at m is equal to 2. So at m is equal to 2, this quadratic would become x squared plus negative 4 negative 2x plus 9 is equal to 0. So that becomes x squared minus 4 minus 2, that's negative 6x plus 9 is equal to 0. And if we factorize this, that would be, but a 3 here and a 3 here, we want to get negative 6x. So x is equal to, x minus 3 is equal to 0, x is equal to 3. So at m equals 2, x is equal to 3. And we can also go on to evaluate the y coordinate at x equals 3. So that will be y is equal to, let's use the equation of the curve that we have here, x squared minus 4x plus 3. So y is x squared minus 4x plus 3. We substitute an x with 3, that's 3 squared minus 4 times 3 plus 3. So that's 9 minus 12. That's minus 3 plus 3, which gives us y is equal to 0. So we know that at m equals 2, the line touches the curve at the coordinates 3, 0. Now let's evaluate at m is equal to negative 10. So again, we're using the same quadratic that we have over here. X squared plus negative 4 negative mx plus 9. So x squared plus negative 4 negative m. So since we have negative 10 here, this will now become negative 10, which is plus 10. X plus 9 is equal to 0. So our quadratic simplifies to give us x squared, but 10 minus 4, that gives us a positive 6. So 6x plus 9 is equal to 0. And if we solve our quadratic, that's x plus 3. X plus 3 is equal to 0. So you get x plus 3 is equal to 0. X must be negative 3. And again, let's evaluate our y coordinate using this equation over here. So y is equal to x squared, so that's negative 3 squared, minus 4 times negative 3 plus 3. So negative 3 squared is 9 plus 4 times 3, which is 12. So that gives us 21 plus 3, which is 24. So y is equal to 24, and therefore the coordinates when x is negative 3 are negative 3, 24. And let's close that bracket. So now we can conclude that therefore m is equal to 2 or negative 10, and our coordinates are 3, 0, which is that set over there, and negative 3, 24, and this would be our final answer. So if the equation 3x plus 2 is equal to 2 over x minus 1. So 3x plus 2 is equal to 2 over x minus 1. Multiply both sides by x minus 1 to get rid of the denominator. So that becomes 3x plus 2 times x minus 1 is equal to 2. So if we expand, that's 3x times x, which gives us 3x squared. But 3x times negative 1 is negative 3x. 2 times x, that's plus 2x. And then 2 times negative 1, that's negative 2. And this is equal to 2. So this becomes 3x squared minus 3x plus 2x, that's minus x, minus 2. Let's bring this 2 to the left hand side, so that's minus 2. And this is equal to 0, so 3x squared minus x minus 4 is equal to 0. Now let's see if we can factorize our quadratic. We have 3x and x is equal to 0. Let's put a 1 here, a 4 here. We want to get negative x. So we want to get a negative 4x plus 3x to give us the negative x. So you end up with 3x minus 4 is equal to 0. X plus 1 is equal to 0. So this becomes 3x is equal to 4. So x must be 4 over 3. And then here x is equal to negative 1. So your final answer would be, therefore x is equal to 4 over 3. X is equal to negative 1. So the equation 8x to the power 6 plus 215 x cubed minus 27 is equal to 0. Okay, so let's just write that out. 8x to the power 6 plus 215 x cubed minus 27 is equal to 0. So to solve a hidden quadratic, what we're going to do is we're going to rewrite the highest power, in this case that's 6, in terms of the lowest power. So we want to rewrite x to the power 6 in terms of x cubed. So that would be 8, and then you've got your x cubed. Now what power do you have to multiply by to get to 6? We'd have to multiply this by 2. So 2 times 3 would then give us 6. Plus, that is 215 x cubed minus 27 is equal to 0. Then we're going to use a substitution so that we can clearly see that this is a quadratic. Because remember, a quadratic is anything that can be written in the form ax squared plus bx plus c is equal to 0. So we're going to say let y equal x to the power 3. So wherever there's an x to the power 3, substitute with y. So that becomes 8 y squared plus 215 y minus 27 is equal to 0. This quadratic doesn't look like it would be easy to factorize by side, so we'll use the quadratic formula. So y is equal to minus b, so that's minus 215, plus or minus the square root of 215 squared minus 4a, which is 8, and c, which is negative 27, and this is all 2 times 8. Let's punch this into our calculator. So that would be negative 215 plus the square root of 215 squared minus 4 times 8 times negative 27, and this is all over 2 times 8, and this gives us y is 1 over 8, and y is, now let's use the negative sign, so negative 215 minus the square root, so that gives us a negative 27. And now remember that we want to get the value for x. The original equation that we had was in terms of x, so we're supposed to solve for x. So we're going to use the substitution to go back to x. So y is equal to x cubed. So we're going to come back here and we're going to substitute y with x cubed. So this would become x cubed is equal to 1 over 8. And this would become x cubed is equal to negative 27. So to get the value of x, we have to take the third root of both sides. So the third root of x cubed and the third root of 1 over 8. So x is equal to, let's punch that into the calculator. That's the third root of 1 over 8. That gives us x is 1 over 2. And then if we do the same for this equation, that's the third root of x cubed, the third root of negative 27. We get x is equal to, if you punch that into your calculator, that gives you negative 3. And this would be our final answer. X is equal to 1 over 2 and x is equal to negative 3. So these are the common questions for quadratics. Go to the topical worksheets, work through those questions until you master the concept. If you don't understand anything, there are detailed explanations below those questions. So let's go through the common questions for functions. Now functions has a lot of variety, so I've just included as many different types of questions as I could find. So let's go through those questions. The function f is defined by f of x is equal to negative 3x squared plus 2 for x is less than or equal to negative 1. Part A, state the range of f. Okay, so if we want the range of any function, it's easier to just sketch the function and then determine its range. Okay, so I'm going to draw our Cartesian plane with our x-axis here, and then we'll have our y-axis over here. We know that our function has the coordinates 0, 2. Since this is basically a completed square form, it will be the equivalent of x plus 0 squared plus 2, so the coordinates would be 0 and 2. Okay, so if we 0, 2 would be somewhere here, and we know that this is a negative quadratic, so it's an upside down curve, so it would look something like that, right? And then we have a domain that we're supposed to follow, which is that x is less than or equal to negative 1. Okay, let me draw that region in red. So x is less than or equal to negative 1 will start somewhere here. We're assuming that negative 1 is over here. So this portion going here would be x is less than or equal to negative 1, and that's the portion that we want. So we need to find the y value when x is equal to negative 1, and we can do that by simply punching negative 1, or substituting x by simply substituting x with negative 1 in f of x. So f of negative 1 is equal to negative 3, negative 1 squared plus 2. F of negative 1 is equal to, that becomes negative 3 plus 2, and that gives us negative 1 as well. So that would be negative 1. And we can tell that our function is going downwards, so our range would be that y is less than or equal to negative 1. We're using the or equal to sign because they also used it in their domain. Okay, let's go back to our blue pen. Part B, find an expression for f inverse of x. Okay, so I should label this. This is B and this is A. So for B, we want f inverse of x. F of x is equal to negative 3x squared plus 2. Let's substitute f of x with y, so this becomes y is equal to negative 3x squared plus 2. Then to get f inverse of x, we're going to make x the subject of the formula. So this becomes 3x squared is equal to 2 minus y. We'll simply interchange these two. And now let's divide both sides by 3. You have x squared is equal to 2 minus y over 3. And then take the square root of both sides. X is equal to plus or minus the square root of 2 minus y over 3. Now we need to pick one of the signs. We cannot have both signs on our inverse. Now this sign will be influenced by the domain of f inverse of x. So our domain is x is less than or equal to -1. So since our domain has the less than sign, we'll take the negative sign. If our domain has the greater than sign, we'll take the positive sign. So x is -√2 minus y over 3. Now let's write it with the correct notation. That's f inverse of x is equal to -√2 minus x over 3, and this would be our final answer. Now let's move on to part C. The function g is defined by g of x is equal to -x squared -1, where x is less than or equal to -1. Part C, solve the equation fg of x minus gf of x plus 8 is equal to 0. Okay, so we need to start by first evaluating fg of x and then evaluating gf of x. So let's start with fg. Okay, so let me just clear out A and B so that we can see everything clearly. So part C, we're saying that let's find fg of x. Fg of x. So we're putting g into f. What's our function f? F is -3x squared plus 2. So wherever there's an x, we're going to substitute with g of x. So we're going to put this there. That's -x squared -1. And then we have squared plus 2 plus 2. And now let's expand this. Fg of x is equal to, so this becomes -3. And if we expand, that's -x squared squared, which gives us x to the power 4. And then we have 2 times minus x squared times -1, which gives us a positive 2x squared. Then finally we have -1 squared, which is a positive 1 plus 2. And let's simplify this further. That's fg of x is equal to -3x to the power 4 minus 6x squared minus 3 plus 2. Fg of x is equal to -3x to the 4 minus 6x squared minus 3 plus 2, that's -1. So that's fg of x. Now we need to find gf of x. So g f of x is equal to, that's -x squared, so we're going to put f here, -3x squared plus 2, and this is squared minus 1. Let's simplify. Gf of x is equal to negative, and then we're going to expand this whole bracket over here. So that's -3x squared, which gives us 9x to the power 4. And then we have 2 times -3x squared times 2, which gives us -12x squared. And then we have 2 squared, which gives us 4 minus 1. So gf of x is equal to -9x to the 4 plus 12x squared minus 4 minus 1. Gf of x is equal to -9x to the 4 plus 12x squared minus 5. Now that we have fg of x and gf of x, we can now solve the equation. So we're simply going to substitute into that equation. So fg of x is -3x to the 4 minus 6x squared, -3x to the 4 minus 6x squared minus 1. And this is supposed to subtract gf of x. Gf of x is -9x to the 4 plus 12x squared minus 5. So that's -9x to the 4 plus 12x squared minus 5. And this is plus 8. And this is all equal to 0. So let's expand our bracket. That's negative 3x to the 4 minus 6x squared minus 1 minus 9x to the 4. So that's plus 9x to the 4 minus 12x squared minus 5, which is plus 5, and then plus 8 is equal to 0. Now group like terms, we've got negative 3x to the 4 plus 9x to the 4, that gives us 6x to the 4. We've got negative 6x squared, negative 12x squared, that's negative 18x squared. And then with negative 1 plus 5, that's 4, plus 8, that's 12. So plus 12 is equal to 0. Let's divide through by 6. That becomes x to the 4 minus 3x squared plus 2 is equal to 0. And you notice that what we have is a hidden quadratic. So to solve this, we have to rewrite x to the power 4 in terms of x squared. So that would become x squared. What do we have to multiply this power by to get 4? We'd have to multiply it by 2. And that's minus 3x squared plus 2 is equal to 0. And then we're going to use a substitution. Let y equal x squared. So wherever there's an x squared, you're going to substitute with y. So that becomes y squared minus 3y plus 2 is equal to 0. And now we're going to factorize our quadratic equation over here. So that would be negative 1 and negative 2. So you get y is equal to 1 and y is equal to 2. And now remember that we are solving for x, we don't want y. So we're going to use our substitution to go back to x. So our substitution is y is equal to x squared. So now wherever there's a y, replace it with x squared. So this becomes x squared is equal to 1. And this becomes x squared is equal to 2. And to get our values of x, we're going to take the square root of both sides. So this becomes x is equal to plus or minus the square root of 1. And this becomes x is equal to plus or minus the square root of 2. So this simplifies to x is equal to plus or minus 1. And then x is equal to plus or minus root 2 is already in its simplest form. Now let's look at our domains to check if all our values are within the given domains. So G has the domain x is less than or equal to negative 1. In fact, both of them have the same domain. So that means we're going to check if our values satisfy the domain x is less than or equal to negative 1. So in this case, we've got x is equal to positive 1 and x is equal to negative 1. This value does not satisfy our domain x is equal to 1. Our domain is only taking negative values. So that means x is equal to positive 1 is outside the domain. And then from here, we've got x is equal to root 2 and x is negative root 2. The positive value is outside the domain, so we're going to disregard it as well. So we're going to conclude that therefore our final answer is x is equal to, we're only taking the negative values since they're the ones that satisfy the domain. So that's negative 1 and negative root 2, and that's the final answer. Function f is defined by f of x is equal to 2x over 3x minus 1, for x is greater than 1 over 3. Part A, find an expression for f inverse of x. Okay, so let's write our function. That's f of x is equal to 2x over 3x minus 1. We're going to substitute f of x with y. So y is equal to 2x over 3x minus 1. Now if we want to get f inverse of x, our goal should be to make x the subject of the formula. So we're going to do that by multiplying both sides by the denominator. So that becomes y times 3x minus 1 is equal to 2x. And then we're going to expand the left-hand side. That becomes 3xy minus y is equal to 2x. Then we're going to put any term that contains an x on the same side, and anything else will move to the other side. So this becomes 3xy. Then we're moving this 2x to the left hand side, so it becomes minus 2x. And the negative y is going to the right hand side, it becomes a positive y. And then now we're going to factor out an x on the left hand side, so that becomes x. And then we have 3y minus 2 is equal to y. And then we're going to divide both sides by the bracket, that's 3y minus 2. So this becomes x is equal to y over 3y minus 2, and this is our inverse. Now let's write it with the correct notation. So that's f inverse of x is equal to, replace the y's with x, so that's x over 3x minus 2, and this would be our final answer. That is part A. And then part B, show that 2 over 3 plus 2 over 3 times 3x minus 1 can be expressed as 2x over 3x minus 1. Okay, so we're showing that this expression over here can be simplified to f of x. Okay, so let's work it out over here. That's B, we've got 2 over 3 plus 2 over 3 times 3x minus 1. So the first thing that we need to do is to combine the two fractions, and they have the common denominator 3 times 3x minus 1. 3 into our new denominator here will cancel that 3, so this becomes 2 times 3x minus 1 plus the 2 over here, that's plus 2. Let's expand the numerator, that becomes 6x minus 2 plus 2, and this is all over 3 times 3x minus 1. And if we simplify our numerator, we have 6x over 3 times 3x minus 1. Then if you cancel out the 3 here, you end up with a 2 on your numerator, and therefore 2x over 3x minus 1, which is our function f of x. So that's part B. And then part C, state the range of f. Okay, so the reason they actually made us express f of x in this form over here is so that it's easier for us to sketch our function for f of x, and we need to sketch our function so that we determine our range for f, which is part C. So if we were to draw a Cartesian plane over here, got a Cartesian plane, this is our x-axis, this is our y-axis. What we have is a rational function, which is just a fancy way of saying that we have a function which is in the form of a fraction. And so all graphs of rational functions stem from the graph of y is equal to 1 over x. And that graph looks like this. It's 2 ears. Looks like that. That's the graph of y is equal to 1 over x. So any other rational function will simply be a transformation of this graph. And the key information that we need here is this value over here. This 2 over 3 will allow us to find our range. That 2 over 3 represents a translation in the y direction. That means we are translating this graph of y equals 1 over x by 2 over 3 units in the y directions. So for example, if we have 2 over 3 here, this will pretty much serve as the x-axis. You see how the x-axis over here is the asymptote, right? So that means for our new function, we'll have the line y is equal to 2 over 3 serving as the asymptote. And also make sure to check what this sign is, because if it's a negative sign, then that means our graph is reflected in the x-axis. But anyways, with what we have, our function would look something like that. And let's check our domain. Our domain is x is greater than a third. You notice that in this bracket here, 3x minus 1 is equated to 0. 3x minus 1 is equal to 0. Our solution will be x is equal to 1/3. So the solution for the bracket would be the asymptote for the x-axis. Just like how in this case, the y-axis here is serving as the asymptote for our original graph of y is equal to 1 over x. But now for our red graph, we're saying that the asymptote is supposed to be 1 over 3. Now it's not going to affect our range like I said before. What you need to just notice is that our graph is going increasing upwards and it's starting from 2 over 3. So our solution would be that y is greater than 2 over 3. Let's check if they used a greater than or equal sign on our domain. No, they did not. So our final answer for C would be y is greater than 2 over 3. Now let's look at a transformation question. A function f is defined by x squared minus 2x plus 5, where x is an element of all real values. A sequence of transformations is applied in the following order to the graph of y equals f of x to give the graph of y is equal to g of x. So first we have a stretch parallel to the x-axis with scale factor half. Then we have a reflection in the y-axis, then stretch parallel to the y-axis with scale factor 3. Find g of x, giving your answer in the form ax squared plus bx plus c, where a, b, and c are constants. Okay, so let's evaluate our transformations here. So we can write g of x as a transformation of f of x. So first we have a stretch parallel to the x-axis with a scale factor of half. So we can write that as f of 2x. So if you have a stretch in the x direction, that means you're multiplying x by the reciprocal of whatever the scale factor is. So our scale factor here is half, our reciprocal is 2. So that means f of 2x represents a stretch parallel to the x-axis with scale factor half. And then we have a reflection in the y-axis. So for a reflection in the y-axis, we then multiply the x by -1. So that would become negative. And then we have a stretch in the y-axis by a scale factor of 3. So that's multiplying f of x by 3. So this becomes g of x is equal to 3f of -2x. And so now we can substitute what is f of x. Well, given that f of x is equal to x squared minus 2x plus 5. So this becomes g of x is equal to 3 times f of -2x. So that means wherever there's an x, you're going to substitute with -2x. So that becomes -2x squared minus 2 times the x here. So that's -2x plus 5. Then let's close our bracket. So g of x is equal to, that's 3 -2x squared gives us 4x squared plus, that's 4x plus 5. And if we expand this, g of x is equal to, that's 12x squared plus 12x plus 15. And this would be the final answer. So that's it for the functions video. Now going to work on topical questions for functions. Welcome to the coordinate geometry section of this crash course. Let's get into the common questions. A circle has equation x minus 1 squared plus y plus 4 squared is equal to 40. A line with equation y equals x minus 9 intersects the circle at points A and B. Part A, find the coordinates of the 2 points of intersection. Okay, so we've got x minus 1 squared plus y plus 4 squared is equal to 40. This is the equation of our circle. And then we have the line, which is y equals x minus 9. Now to get the coordinates of the 2 points of intersection, we have to solve them simultaneously. So we're going to substitute y with x minus 9 in the equation of the circle. So that will become x minus 1 squared plus x minus 9 plus 4 squared is equal to 40, which is x minus 1 squared plus x minus 9 plus 4, that's x minus 5 squared is equal to 40. Okay, now let's expand our quadratic. So that becomes x squared minus 2x plus 1 plus x squared minus 10 x plus 25 is equal to 40. Now let's group like terms. X squared plus x squared, that gives us 2x squared minus 2x minus 10x, that's minus 12x. Then 1 plus 25, that's plus 26. Let's move this 40 to the left hand side, so it becomes minus 40, and this is equal to 0. So that becomes 2x squared minus 12x. 26 minus 40, that's minus 14, is equal to 0. Divide through by 2 to simplify the quadratic. That's x squared minus 6x minus 7 is equal to 0. And now let's factorize our quadratic. So we want factors of negative 7 that add up to negative 6. So that's negative 7 plus 1. And so we get our solutions as x is negative 1 and x is 7. Now we want to evaluate our y coordinate. So y is equal to x minus 9. So at x is negative 1, y is equal to negative 1, negative 9, and y is equal to negative 10. And then at x is 7, y is equal to 7 minus 9, and y is equal to negative 2. And we can conclude they want the coordinates of the 2 points of intersection. We can conclude that the two coordinates are negative 1, negative 10, and 7, negative 2. And this would be our final answer for part A. Part B, find an equation of the circle with diameter AB. Okay, so for B, we're going to say that this set of coordinates will be A. So A is negative 1, negative 10, and then B would be 7 and negative 2. Now let's sketch a diagram of our problem. Got a circle, and this would be our center, and we're told that this circle that we're dealing with has AB as its diameter. So I'm going to assume that A would be somewhere here, and then B would be somewhere here. So A is this point over here, and B is that point over there. So to get the equation of the circle, we need the coordinates of the center, and in this case, the center is the midpoint of AB. So if we find the midpoint of AB, we get the coordinates of the center. So M is equal to the average of our x coordinates, so that's negative 1 plus 7 over 2, and then the average of the y coordinates, negative 10, negative 2 over 2. And so our midpoint has the coordinates 7 minus 1, that's 6 over 2, that's 3. And then negative 10, negative 2, that's negative 12 over 2, that's negative 6. So the coordinates of our center here are 3, negative 6. And then we also need the radius for the equation of the circle. So we can tell that from A to the center, that's equal to the radius. So if we get that length, that will give us our radius. So our radius is the x coordinate of A, negative 1, minus the x coordinate of our center, that's 3 squared, plus the y coordinate at A, negative 10, minus the y coordinate at our center, that's negative 6, so plus 6 squared. And let's punch this into the calculator. So that's the square root of negative 1, negative 3 squared plus negative 10 plus 6 squared, and this is equal to 4 root 2. And for the equation of the circle, what we actually want is r squared, so we're just going to square that. That will give us 32, and we can conclude that the equation of our circle with diameter AB is x minus 3 squared plus y minus 6, so that becomes plus 6 squared is equal to r squared, which is 32, and this would be our final answer. Points A and B have coordinates 5, 2, and 10, negative 1, respectively. Part A, find the equation of the perpendicular bisector of AB. Okay, so let's sketch what this would look like. We've got A and B, so A is 5, 2. We'll just assume that A is somewhere here. This is A. And then we've got B, which is 10, negative 1. So B would be somewhere down here. If we can just join these 2 points together, that's A and B. So the perpendicular bisector will be a line that passes through AB, and it passes through AB at the midpoint, and it also forms a right angle as it passes through AB since it is perpendicular to AB. Now, to get the equation of our perpendicular bisector, we need its gradient and a point that lies on the perpendicular bisector. So let's start with the gradient. To get the gradient of the perpendicular bisector, we're first going to get the gradient of our line AB. And so our line AB, we're going to say the change in y, that's 2 minus 1, so 2 plus 1, over 5 minus 10. 5 minus 10, punch that into the calculator, 2 plus 1 over 5 minus 10, we get negative 3 over 5. So the gradient of AB is equal to negative 3 over 5. Now we know that these two lines are perpendicular, so the gradient of the perpendicular bisector is therefore equal to the negative reciprocal. So that means we're flipping our fraction over here and then we're going to change this sign. That's what negative reciprocal means. Or you could just simply use m1 times m2 is equal to negative 1. It's the same thing. So our perpendicular bisector has the gradient 5 over 3. Now we need to find the coordinates of a point that lies on our perpendicular bisector. Since it's a bisector, it splits the line AB in half, and therefore it passes through the midpoint of AB. So let's find the midpoint of AB, since the midpoint of AB also lies on the perpendicular bisector. So the midpoint of AB would be the average of our x coordinates, that's 5 plus 10 over 2, and then the average of our y coordinates, 2 minus 1 over 2. So that gives us 5 plus 10, 15 over 2, and then 2 minus 1, that's 1 over 2. So 1 over 2, these are the coordinates of the midpoint, and that lies on the perpendicular bisector. Now we can use y equals mx plus c, where m is equal to our gradient over here, 5 over 3, and then our perpendicular bisector is passing through the point 15, 2, and 1 over 2. So y here is half, so that's half is equal to m, which is 5 over 3, times x, which is 15 over 2, plus c. So that's half is equal to 5 over 3 times 15 over 2, and that gives us 25 over 2, plus c. Let's make c the subject of the formula, so that c is equal to half minus 25 over 2, and that gives us minus 12. So this means that the equation of our perpendicular bisector is y is equal to our gradient 5 over 3 x minus 12, and this would be our final answer. So that's it for the coordinate geometry. You can go on to the topical questions and work on them. See you in the next video. Welcome to the circular measure section. Let's get into it. In the diagram, arc AB is part of a circle with center O and radius 8 centimeters. Arc BC is part of a circle with center A and radius 12 centimeters, where AOC is a straight line. Part A, find the angle BAO in radians. Okay, so BAO would be this angle here, and we want it in radians. So what we can do, you notice that AOB is a triangle, which is isosceles since this side is equal to that side. So we can split it in half like that. And this will be a right angle. Now that means this side will be 6 and then that side will be 6 in length. And now we can simply use SOHCAHTOA to evaluate our angle BAO, which is this angle over here. Let's call it angle theta. Notice how this 6 is the adjacent, and then this 8 would be our hypotenuse. So it means we're using cos. We could say that cos theta is equal to the adjacent, which is 6, over the hypotenuse, which is 8. So theta is equal to arc cos of 6 over 8. Punch that into a calculator, make sure you're in radians. So that's arc cos of 6 over 8, and that gives us 0.723, correct to 3 decimal places. So we could conclude that angle BAO is equal to 0.723. This is part A. Now let's move on to part B. Let's just clean up our diagram. Find the area of the shaded region. Okay, so to get the area of our shaded region, we have a sector. I'm going to draw the sector in red. That's from A to B, and then the arc BC, and then we've got from C to A. That's the sector. So if we want the area of the shaded region, we could say this sector minus the triangle that we have that's in white over here, triangle BAO, and that should give us the area of our shaded region. So we're saying sector, this is part B, sector, that is sector ABC minus our triangle BAO. Okay, so to get the area of sector ABC, we're going to say half r squared theta. And half r squared theta, in this case, our radius is this 12 over here. Half times 12 squared times theta, which we evaluated in part A, which is 0.723. But we're going to use the exact value that we have here so that we don't round off prematurely. So that's arc cos of 6 over 8. And if we simplify that, that gives us, that's 1 over 2 times 12 squared times arc cos of 6 over 8, which is 52.0369, correct to 4 decimal places. And then we need to get the area of our triangle BAO. And to do that, we're going to use the formula half AB sine theta. And we're subtracting here half AB sine theta. So that would be half times our length of OA times AB sine BAO. Sine BAO, which we say it is arc cos of, in fact, let's just write it as BAO for now. BAO, and this is subtracting. We simply substitute now half times OA has a length of 8 centimeters, AB has a length of 12 centimeters, and then sine, we say that's arc cos of 6 over 8. Let's punch this into our calculator. 1 over 2 times 8 times 12 times sine arc cos of 6 over 8. Let's close our brackets. That gives us 52.0369 minus 31.7490. This is correct to 4 decimal places. And if we simplify this, 52.0369 minus 31.7490, we get 20.3, correct to 3 significant figures, and that would be our final answer. Let's move on to part C. Find the perimeter of the shaded region. Okay, let's just clear our diagram. So the perimeter of the shaded region consists of this line OB, and then OC, and then the arc BC over here. So perimeter is equal to OB plus OC plus arc BC. So we know that OB is 8 centimeters, and then OC is equal to AC, which is the radius, minus this 8 centimeters. So that would be 12 minus 8 plus arc BC. Arc BC is S is equal to R theta. In this case, our radius is 12, and then theta is arc cos of 6 over 8. And so let's punch this into our calculator to get our perimeter. So that's 8 plus 12 minus 8, which is 4, plus 12 arc cos of 6 over 8. And this would give us 20.7, correct to 3 significant figures, and that would be our final answer. The diagram shows a chord going around a pulley and a pin. The pulley is modeled as a circle with center O and radius 5 centimeters. The thickness of the chord and the size of the pin P can be neglected. The pin is situated 13 centimeters vertically below O. Points A and B are on the circumference of the circle, such that AP and BP are tangents to the circle. The chord passes over the major arc AB of the circle and under the pin such that the chord is taut. Calculate the length of the chord. Okay, so let's create an expression for the length of our chord. So we know that our chord runs from A to P. So we've got AP, then it runs from P to B, so that's BP, and then we have this major arc AB going right round. Then we've got major arc AB. Okay, so we need to get the lengths of AP and BP first. So AP and BP are equal in length since they're both tangents stemming from the same point P. And we can tell that the triangle AOP is a right angled triangle over here. So that means we can use SOHCAHTOA to evaluate the length of AP since we know the length of this side and that side. So we can simply say that AP is equal to the square root of the hypotenuse squared minus 5 squared. So AP is equal to, that is the square root of 13 squared minus 5 squared, and that gives us 12. So this becomes 12 plus 12 plus our major arc AB, major arc AB. So that's 24, that's major arc AB, major arc AB. Now to get the arc length of our major arc, we need this angle over here. And we can get that by first getting this angle here. So let's start by finding this angle over here in the right angle triangle. So we have this side as 5, that side would be the adjacent, and then we have our hypotenuse as 13. We're going to call this angle theta and say that cos theta is equal to adjacent being 5 over the hypotenuse, which is 13. So theta is equal to arc cos of 5 over 13, and we're going to leave it as the exact value as it is. And we're saying that the angle that we want is this angle over here, which would then help us to get this angle over here. So that this angle over here that I've drawn, this big angle, is 2 times theta. So that angle will be 2 arc cos of 5 over 13. And now to simply get this blue angle over here, we can subtract this from 2 pi radians, which is the same as 360 degrees. So 2 pi minus 2 arc cos of 5 over 13 is the angle that we're looking for. And now we can use S is equal to R theta. S is equal to R theta. S is equal to our radius is 5 over here, that's our radius, 5 times our angle, which is 2 pi minus 2 arc cos of 5 over 13. Let's punch that into the calculator. That's 5 times 2 pi minus 2 arc cos of 5 over 13. And this gives us 19.6559, correct to 4 decimal places, and we can substitute here. So that becomes 24 plus 19.6559, which gives us, when we punch into the calculator, we get 43.7, correct to 3 significant figures, and this would be our final answer. So that's it for the circular measure video. Go on to the topical questions and see you in the next video. Welcome to the trig section of this crash course. Let's get into it. A curve has equation y equals 2 plus 3 sine half x, for x is between 0 and 4 pi. Part A, state the greatest and least values of y. Okay, so if we want to get the greatest value of y, we simply substitute this part with 1. So it would become y is equal to 2 plus 3 times 1, and we get 5. That is the greatest value. And if we want to get the least value, we substitute with negative 1. So that's y is equal to 2 plus 3 times negative 1, which gives us negative 3 plus 2, which is negative 1. So for part A, we can conclude that greatest value is equal to 5, and least value is equal to negative 1. Then part B, sketch the curve. Okay, so let's start by drawing our Cartesian plane. So this would be our y-axis, and then this here would be our x-axis. And we say the greatest value for a function is 5. So 1, 2, 3, 4, 5. That's here. And then the least value is negative 1. Okay, so we're going to sketch our function using transformation. So it's y is equal to 2 plus 3 sine 1 over 2x. So let's start with this transformation here. That's a translation in the y direction by 2 units. So usually the graph of y equals sine x starts at 0. So now we've translated by what? By 2 units in the y direction. This is 2 over here. So let's draw a dotted line going right through. So this is now the line that will split our graph in half. And then we have this 3 over there. That's the stretch that shows us that our maximum value will now be at 5 and our minimum value will now be at negative 1. Then finally, this half over here shows us that from 0 to 2 pi, we only have half of a full cycle. But remember that we're required to sketch from 0 to 4 pi. So since we have half a period from 0 to 2 pi, it means we have a complete period, we have a complete cycle from 0 to 4 pi. So now let's sketch our graph. So it should be something like that, with the maximum point at 5 and the minimum point at 1. So this part here will be 4 pi, and then the halfway point over here will be 2 pi. And this is the graph of y equals 2 plus 3 sine half x from 0 to 4 pi. Part C, state the number of solutions of the equation 2 plus 3 sine half x is equal to 5 minus 2x. So this is our trig function, the one that we've sketched. And then we're now given the function y equals 5 minus 2x. So when we talk of number of solutions, in other words, we're simply talking about the points of intersection. How many points of intersection do we have? So let's sketch our graph of y equals 5 minus 2x on the same graph. So we need 2 points since this is a graph of a straight line. When x is 0, we have y as 5. And then, so that's this point over here. and then we need another point. So for our other point, we'll substitute x with 1. So when x is 1, that's 5 minus 2. Y is 3. So 3 is around half of 2 pi because 2 pi is around 6.28. So 3 would be somewhere here. So our line is going through these 2 points over here. So our line looks like that. This is the line of y equals 5 minus 2x. Now you can tell that we only have one point of intersection, so the number of solutions would be one solution, and that would be our final answer. Number 10, part A. Prove the identity 1 minus 2 sine squared theta over 1 minus sine squared theta is identical to 1 minus tan squared theta. Okay. So for this one, we will work from the right hand side going to the left hand side. So that's 1 minus tan squared theta. Let's rewrite tan squared theta using the identity tan squared theta is identical to sine squared theta over cos squared theta. So that's 1 minus sine squared theta over cos squared theta. Now notice how on the left hand side we have one single fraction, so that means we need to combine these two to become one fraction by giving them a common denominator. So that's cos squared theta, and our numerator becomes cos squared theta minus sine squared theta, and then this becomes, we can use the identity cos squared theta is identical to 1 minus sine squared theta, because we're trying to end up with these sine squared thetas over here. So wherever there's a cos squared theta, you're going to replace it with 1 minus sine squared theta. So our numerator becomes 1 minus sine squared theta minus sine squared theta, and this is all over 1 minus sine squared theta. When you simplify it, it becomes 1 minus 2 sine squared theta over 1 minus sine squared theta, and we have proved our identity. This is part A. Now part B says, hence solve the equation 1 minus 2 sine squared theta over 1 minus sine squared theta is equal to 2 tan to the 4 theta. So we can simply replace this bit with 1 minus tan squared theta, since that will be easier to work with. So that becomes 1 minus tan squared theta is equal to 2 tan to the 4 theta. Let's put everything on one side. That is 2 tan to the 4 theta plus tan squared theta minus 1 is equal to 0. So notice that this is a hidden quadratic. So we're going to solve our hidden quadratic by factorization. We've got 2 tan squared theta, and then we've got tan squared theta. So that's 2 tan squared theta minus tan squared theta to give us a positive tan squared theta. You can alternatively, use the substitution method of saying let y equals tan squared theta, tan squared theta. So 2 tan to the 4 theta is the same as 2 tan squared theta squared plus tan squared theta minus 1 is equal to 0. And then we say wherever there's a tan squared theta, replace it with y. So that's 2y squared plus y minus 1 is equal to 0. And then you'd solve this quadratic, and you'd notice that you'd end up with the same solution. Okay, but in this case, we're not going to use this method. We'll assume that you're now comfortable with solving hidden quadratics. So equate each bracket to 0. That becomes 2 tan squared theta minus 1 is equal to 0. And then we've got tan squared theta plus 1 is equal to 0. So this becomes tan squared theta is equal to 1 over 2. And this is tan squared theta is equal to -1. Let's work with this equation for now. Take the square root of both sides, you get tan theta is equal to plus or minus the square root of half. Let's scroll down. Let's write these as two separate equations. So that's tan theta is root half and tan theta is equal to negative root 1 over 2. So theta is arctan of root 1 over 2. Theta is equal to, I believe we're in degrees. Yes, we're in degrees. So let's punch that into a calculator. Make sure you're in degrees. That is arctan of root 1 over 2. And that gives us 35.2643898. Okay, and what is our interval? From 0 to 180. So this is the only solution for this equation from 0 to 180. Now let's evaluate tan theta is equal to negative half, negative root half. So tan theta is equal to negative root half. Theta is equal to arctan of negative root half. Theta is equal to, punch that into your calculator. Again, make sure you're in degrees. That's negative 35.2643898. Okay, and the solution is not between 0 and 180, so we're going to use the formula PV plus 180n. So at n is equal to 1, at n is equal to 1, our principal value is this value of theta over there. So PV plus 180 times 1, that's the negative 35.26 and so on, plus 180 times 1, you get 144.7356103, and that's within the given interval. So that would also be another solution. Now we still have an equation that we didn't evaluate, which was tan squared theta is equal to negative 1. If we take the square root of both sides here, you end up with tan theta is equal to root negative 1, and that gives us no solutions, since that's the square root of a negative number. We can now conclude that our solutions that are within the given interval are these two solutions. So we can say, therefore, theta is equal to 35.3 degrees and 144.7 degrees, and this would be our final answer. Now let's look at a transformation question. The curve y equals sine x is transformed to the curve y is equal to 4 sine half x minus 30 degrees. Describe fully a sequence of transformations that have been combined, making clear the order in which the transformations are applied. Okay, so we have our curve here, 4 sine of 1 over 2x minus 30 degrees. Right, so let's start first. Let's ignore the order for now. We're just going to identify the transformations that are there. So we have this negative 30 over there. That's a translation in the x direction. Translation, x direction, x direction. And that is by 30 degrees. By 30 degrees. And remember that when we're talking about the translation in the x direction, when you're now given the translation vector, or the amount of units that have been shifted by, you take the opposite sign. Since here we have negative 30 degrees inside the bracket, it means we have actually moved by positive 30 degrees. And then the next transformation that we have is this half x, that is a stretch in the x direction by a scale factor of, our scale factor is the reciprocal of that number that you see, so our scale factor is 2. And then finally we have this 4 over there, that is a stretch in the y direction by scale factor of 4. So for y, you take it exactly as it is, for x, you're going to take the reciprocal. And now they talked about the order. They said making clear the order in which the transformations are applied. Now, the order in which transformations are applied, let me just bring this up here. Bring this up to our question. Right. So the order in which transformations are generally applied is as follows. There's the list. We've got translation in the x direction, straight in the x direction, blah, 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 blah. Here's the order that you use. And now we've written down the three transformations that we have. And you can tell that they're already in the order that is suggested by this guideline. So this would be our first transformation, and then our second transformation, and then our third transformation. So a general rule of thumb is that you're going to start from the transformation that's at the far right, and then you're going to work backwards. That's the general rule. Or you could just memorize this list over here to get your order of transformations. So that's it for the trig video. You can now work on the topical questions. See you in the next video. Welcome to the series section of the crash course. Let's get into it. Number 2, part A. Find the first three terms in the expansion in ascending powers of x of 2 plus 3x to the power 4. Okay, so that's 2 plus 3x to the power 4. So we're going to use our formula for binomial expansion, and we want the first three terms. So the first term will be 2 to the power n, which is 4, plus we do the next term is 4 choose 1 times 2 to the power 3 times 3x to the power 1 plus 4 choose 2 times 2 to the power 2 times 3x to the power 2. And these are the first three terms. Now let's simplify the coefficients. So 2 to the power 4 gives us 16, and then 4 choose 1, that's 4, times 2 cubed, which is 8, times 3x, plus 4 choose 2, that's 6, times 2 squared, which is 4, times 3x squared, so square the 3 and then square the x. So 3 squared is 9, and then x squared. And if we simplify, this is 16 plus 4 times 8, that is 32 times 3, 96x. And then finally, we've got 6 by 4 by 9, and that gives us 216x squared. And this would be our final answer for part A. Part B. Find the first three terms in the expansion in ascending powers of x of 1 minus 2x to the power 5. Okay, so that's 1 minus 2x to the power 5. So that's 1 to the power 5 plus 5 choose 1 times 1 to the power 4 times, in this case, our second term is negative 2x. Also consider the negative sign, plus 5 choose 2 times 1 to the power 3 times negative 2x squared. Now let's simplify our coefficients. So 1 to the power 5, that's 1, plus 5 choose 1, that's 5. 1 to the power 4, that's 1, times negative 2x, plus 5 choose 2, that's 10, times 1 cubed, that's 1, times negative 2x squared. So negative 2 squared gives us 4, and then we have x squared. Now let's simplify, that's 1 minus 10x plus 40x squared, and that's our final answer for part B. So this is B, this is A, and now on to part C. Hence, find the coefficient of x squared in the expansion of 2 plus 3x to the power 4, that was A, times 1 minus 2x to the 5, that was B. So what we have here is we've got 2 plus 3x to the power 4 times 1 minus 2x to the power 5, which were part A and part B. We can simply substitute these with their respective expansions. So for A, we had this expansion, so that becomes 16 plus 96x plus 216x. squared. And then for b, our expansion is 1 minus 10x plus 40x squared. 1 minus 10x plus 40x squared. Now we want the coefficient of x squared. So we need to find the numbers that will multiply to give us a term in x squared. For example, if you multiply 16 by 40x squared, you get a term in what? In x squared. So that's 16 times 40x squared. You multiply 96x by negative 10x, you get a term in x squared. So that's 96x times negative 10x. And finally, if you multiply 216x squared by 1, you get a term in x squared. Now let's simplify this. So we have 16 times 40, that is 640x squared. Then we have 96x times negative 10x, so that's negative 960x squared. Finally, you have 216x squared. Now let's simplify the coefficient of x squared. That's 640 minus 960 plus 216, and this gives us negative 104x squared. So that means that the coefficient of x squared is negative 104, and this would be our final answer. The first, second, and third terms of an arithmetic progression are k, 6k, k plus 6 respectively. Part A, find the value of the constant k. Okay, so we have a is equal to k, that's our first term, and then u2, our second term, is equal to 6k, and then u3 is equal to k plus 6. So we can create two equations by simply finding the common difference. So we can say the common difference d is equal to u2 minus the first term, so the second term minus the first term, which is 6k minus k. We could also say that the common difference is equal to the third term minus the second term, so k plus 6 minus 6k. So let's simplify this. That's d is equal to 6 minus 5k. And now we have two equations in terms of d and k, and we can solve this simultaneously to evaluate k. So let's equate our two equations. Before we do that, actually we can simplify this further. That's 6k minus k, so that's 5k. And so we get 5k is equal to 6 minus 5k. That becomes 5k plus 5k is equal to 6. So 10k is equal to 6. K is equal to 6 over 10. Therefore, k is equal to 3 over 5. And that is our final answer for part A. Part B, find the sum of the first 30 terms of the progression. Okay, so now that we know what k is, we can now say that our first term, a, we said a is equal to k, so a must be equal to 3 over 5. And we say d is equal to 5k, so d is equal to 5 times 3 over 5. And this means that d is equal to 3. Now let's evaluate the sum of the first 30 terms. So the sum of the first 30 terms is equal to half times 30 times 2 times a, which is 3 over 5, plus n minus 1, that's 30 minus 1, d, which is 3. Now let's punch this into our calculator, and we should get our answer. So that's half times 30 times 2 times 3 over 5 plus 30 minus 1 times 3, and that gives us 1323, and this would be our final answer. A geometric progression is such that the third term is 1764 and the sum of the second and third terms is 3444. Find the 50th term. Okay, so we've got a GP, and we are given that the third term, that's u3, is equal to 1764. and we are given that the sum of the second term and third term, so that's u2 plus u3, is equal to 3,444. And then they're saying find the 50th term. So to find the 50th term, first we need to find what our first term is, and we need to find what our common ratio is. So let's start by first evaluating what u2 is. Since we know what u3 is, we can say that u2 plus u3 is 1,764 is equal to 3,444. u2 is equal to 3,444 minus 1,764, and that is 1,680. So that's u2. So now that we have u3 and u2, so u3 under geometric progression can be written as ar squared, and this is equal to 1,764. Then u2 is ar, which is equal to 1,680. So now we have two equations in terms of a and r, and we can solve them simultaneously to evaluate both the values of a and r. So here we'll make r the subject of the formula. That becomes 1,680 over a. Let's substitute that into this equation. That becomes 1,680 over a, and this is squared. This is equal to 1,764. So this ends up being 1,680 squared, 1,680 squared. That is a very big number, 2,822,400. And then we've got a squared. And outside the bracket, we still have the a that's multiplying. This is equal to 1,764. So the a will cancel with that squared. And so you end up with the 2 million over 2,822,400 over a, and this is equal to 1,764. So a must be equal to 2,822,400 over 1,764. Let's punch this into the calculator. That gives us 1,600. So a is equal to 1,600. Now let's evaluate r. R is 1,680 over a, so that's over 1,600. R is equal to, let's punch that into the calculator, and we get 21 over 20. Now that we have our values for a and r, we can find the 50th term. So we can do that using the formula for the nth term. U50 is equal to AR to the 50 minus 1, which is 49. So U50 is equal to 1,600 times 21 over 20 to the power 49. Let's punch this into a calculator. That is 1,600 times 21 over 20 to the power 49, and you get 17,474.13301. Okay, this would be the 50th term, but remember, if they don't specify the degree of accuracy, we always give our answer correct to 3 significant figures. So that becomes 17,500, and that is our final answer. So that's it for the series video. You can now go on to do the topical questions, and see you in the next video. The equation of a curve is y equals 54x minus 2x minus 7 cubed. Part A, find dy dx and d squared y dx squared. Okay, so we're given the equation y equals 54x minus 2x minus 7 cubed. Let's find our first derivative, dy dx. So if we differentiate 54x, we get 54. And then let's bring down our power there. That becomes 3, 2x minus 7. Subtract 1 from the power, that becomes 2. Times differentiate 2x minus 7, you get 2, so multiply by 2. And if we simplify this, dy dx is equal to 54 minus 3 times 2, that's minus 6, times 2x minus 7 to the power 2. That is dy dx. Now let's find the second derivative. So that's basically differentiating dy dx. If you differentiate 54, you get 0. And now let's differentiate the second term. So we've got negative 6, bring down the power, that's times 2. 2x minus 7, subtract 1 from the power, that becomes 1. So we leave it like that. Differentiate the inner function, you get 2, so multiply by 2. So d squared y dx squared is equal to negative 6 times 2, that's negative 12 times 2, negative 24 times 2x minus 7. So dy dx, so we can conclude that dy dx is equal to 54 minus 6 times 2x minus 7 to the power 2. And then our second derivative is negative 24 times 2x minus 7. Part B, find the coordinates of each of the stationary points on the curve. Okay, so this is part A. Now we're going on to part B. So we want the coordinates of the stationary point. To do that, we're going to equate dy dx to 0. So 54 minus 6 times 2x minus 7 squared is equal to 0. Notice how our gradient function is already in its completed square form. So we use the completing the square method to solve our quadratic. So that becomes equal to 54. Divide both sides by 6. So 2x minus 7 squared is equal to 54 over 6, which is 9. Take the square root of both sides. 2x minus 7 is equal to plus or minus the square root of 9, which is 3. Add 7 to both sides. 2x is equal to 7 plus or minus 3. Divide both sides by 2. So you get x is equal to 7 plus or minus 3 over 2. And this gives us x is equal to 7 plus 3, that's 10 over 2. So that gives us 5, or 7 minus 3, which is 4, divided by 2, that gives us 2. Since we want the coordinates, we also have to evaluate the y coordinates. Y is equal to, what's our equation? 54x minus 2x minus 7 cubed. So 54x minus 2x minus 7 cubed. Let's evaluate at x is equal to 5. Let's just scroll up. That is y is equal to, substitute x with 5, minus 2 times 5 minus 7 to the power 3. Let's punch that into the calculator. That is 54 times 5 minus 2 times 5 minus 7 to the power 3. And that gives us 243. Now let's evaluate at x is equal to 2. So that's y is equal to 54 times 2 minus 2 times 2 minus 7 to the power 3. Y is equal to, so substitute into your calculator, and we get 135. 135. So we can conclude that the coordinates of our stationary point are 5, 243, and 135. And this is our final answer. Part C, determine the nature of each of the stationary points. Okay, so to do that, we can use our second derivative over here. Negative 24 times 2x minus 7. So if x is equal to 5 and x is equal to 2, so if x is equal to 5, our second derivative will be negative 24 to substitute x with 5. This would give us, let's punch this into the calculator, negative 24, 2 times 5 minus 7 That gives us negative 72. So this point would be a maximum point since its second derivative is negative. Then at x is equal to 2, that's negative 24. 2 times 2 minus 7 is equal to, let's punch that into the calculator. You get positive 72. So this would be a minimum point. So we could conclude that at x equals 5, d squared y dx squared is less than 0. Hence, this is a maximum point. Hence, maximum then at x is equal to 2. Our second derivative, d squared y dx squared, is greater than 0. Hence, minimum point. And this would be our final answer. Now let's look at this question. The diagram shows the line x is equal to 5 over 2. Part of the curve y is equal to half x plus 7 over 10 minus 1 over x minus 2 to the power 1 over 3, and the normal to the curve at the point A, 3, 6 over 5. Find the x coordinate of the point where the curve meets the x-axis. So we want to find the x coordinate here. So what we need to do first is to find the equation of the normal, and we can do that by finding the gradient of the normal and then using the point A together with the gradient to get our equation. So to get the gradient of our normal, we first have to find the gradient of the tangent dy dx. So let's start by differentiating our function. That's y is equal to half x plus 7 over 10 minus, let's bring this bracket up to the numerator, so that's x minus 2 to the power negative 1 over 3. And now if we differentiate, dy dx is equal to, if you differentiate half x, you get a half. If you differentiate a constant, you get 0. And then we've got negative, bring down the negative 1/3, negative 1/3, then that's x minus 2. Subtract 1 from the power, so that becomes negative 4 over 3 multiplied by, differentiate the inner function, you get 1. And so dy dx is equal to 1 over 2 minus 1 over 3, which gives us positive 1 over 3, x minus 2 to the negative 4 over 3. And now we want the gradient of the tangent at A. We know that A has the coordinates 3, 6 over 5. A has the coordinates 3, 6 over 5. So if we substitute x with 3, we get the gradient of the tangent at A. So that's half plus 1/3 times x, which is 3, minus 2 to the power negative 4 over 3. And let's punch that into the calculator. 1 over 2 plus 1 over 3 times 3 minus 2 to the power negative 4/3. That gives us 5 over 6. So the gradient of the tangent is 5 over 6. We know that the normal is perpendicular to the tangent, so that means the gradient of the normal should be the negative reciprocal of 5 over 6, meaning that the gradient of the normal, call it m normal, is equal to, simply flip this fraction and change its sign. So that's negative 6 over 5. Now that we have the gradient, negative 6 over 5, and we have a point that lies on the normal, we can find the equation of the normal using y is equal to mx plus c. So our y value is 6 over 5, 6 over 5, which is equal to m, our gradient, which is negative 6 over 5, times x, which is 3, plus c. So that 6 over 5 is equal to negative 6 over 5 times 3, which is negative 18 over 5, plus c. So c is equal to 18 over 5 plus 6 over 5, and that gives us 24 over 5. This means that the equation of our normal is therefore y is equal to negative 6 over 5x plus 24 over 5. Now we want to find the x coordinate where the normal meets the x-axis. We know that at the x-axis y is equal to 0. So let's simply substitute y with 0 here and evaluate x to get our x coordinate. So that's plus 24 over 5. So this becomes 6 over 5x is equal to 24 over 5. And now we need to multiply both sides by 5 over 6 to get x. So that's 24 over 5 by 5 over 6. And that gives us x is equal to 4. So this means that the x coordinate where the normal meets the x-axis is x is equal to 4. And this is our final answer. The function f is defined by f of x is equal to 2 minus 3 over 4x minus p, for x is greater than p over 4, where p is a constant. Find f prime of x and hence determine whether f is an increasing function, a decreasing function, or neither. Okay, so let's start by finding our first derivative, f prime of x. In fact, let's first write our equation here. 2 minus 3, let's bring this 4x minus p to the numerator. So that's 4x minus p to the power negative 1. Now let's find our first derivative. If you differentiate a constant, you get 0. Then with negative 3, bring down the power. That's times negative 1. 4x minus p. Then subtract 1 from the power. That becomes negative 2. Differentiate your inner function, you get 4. And so f prime of x is equal to negative 3 times negative 1, that gives us positive 3, multiplied by 4, that gives us 12. 4x minus p to the negative 2. Now let's just take the 4x minus p back to the denominator to make our power positive. So that's 12 over 4x minus p to the power 2. Now we need to determine whether f is an increasing function, decreasing function, or neither. And to do that, we're going to use f prime of x. So f prime of x is known as the gradient function. If a function is considered an increasing function, it has a positive gradient. If a function is considered a decreasing function, it has a negative gradient. So in this case, if f prime of x is positive for all values of x, then it means we have an increasing function, since it's a gradient function. If it's negative, we have a decreasing function. Okay, so now what we're going to do, we're going to analyze, let's analyze our denominator over. We've got 4x minus b squared. So this squared, what it means, for whatever value of x that you substitute, it doesn't matter what value of x you substitute, it's always going to be positive because we're always going to square the final value. And if you check your numerator, in this case that's the 12, that's positive as well. So it means overall the function will always be positive, and therefore f prime of x is an increasing function. So the argument that you have to make is that f prime of x is an increasing function, because the denominator is squared, denominator is squared. So for all values of x, so for all x, the denominator is positive. The denominator is positive. And your numerator 12 is also positive. And numerator is also positive. Numerator is also positive. Hence, f prime of x is positive, and that is why f prime of x is an increasing function, and you leave it there. Number 14, a curve is such that dy dx is equal to 6 over 3x minus 2 squared, and a 1 minus 3 lies on the curve. A point is moving along the curve, and at a, the y-coordinate of the point is increasing at 3 units per second. Find the rate of increase at a of the x-coordinate of the point. Okay, so we're given that dy dx is equal to 6 over 3x minus 2 squared. And then we're given the point a, 1, negative 3. Then we're given that the y-coordinate is increasing, so that's dy dt at a rate of 3 units per second, so that's 3. And then we want to find the rate of increase of the x-coordinate, so we want dx dt. We don't know what that is, and we want to find it at a. So what we're going to do is we're going to construct a chain rule for dx dt using dy dx and dy dt. So dx dt is equal to, you can say dx dy times dy dt. So dy dt we already have. Dx dy we can get it from dy dx. So we are evaluating this at the point a. So dy dx at a would be equal to 6 over 3, the x-coordinate at a is 1, times 1 minus 2, this is squared. So you get dy dx is equal to, let's punch that into the calculator, that is 6 over 3 minus 2 squared, so that's 6 over 1. That's 6. And now notice that we want dx dy, not dy dx. So what we're going to do is we're going to flip the fraction, right? This can be written as 6 over 1. So what you do on one side, you also do on the other side. So if we flip on the left hand side, we'll flip on the right hand side. So this becomes dx, and you scroll up so it's clear, becomes dx dy is equal to, if we flip the right hand side, that becomes 1 over 6. And now we can simply go back to our chain rule and substitute. So you get dx dt is equal to dx dy, which is 1 over 6, times dy dt, which is 3. So dx dt would be equal to 3 over 6, which is 1 over 2 units per second. And this would be our final answer. So that's it for the differentiation video. You can now go on to the topic of questions. See you in the integration video. Welcome to the integration section of this crash course. Let's get into it. The equation of a curve is such that dy dx is equal to 4 over x minus 3 cubed, for x is greater than 3. The curve passes through the point 4, 5. Find the equation of the curve. Okay, so to get the equation of the curve, we have to integrate dy dx. So let's start by writing dy dx. Dy dx is equal to 4. We're going to bring the x minus 3 cubed to the numerator as x minus 3, and then the power becomes negative. So when we integrate, we get y is equal to, that's 4, x minus 3, add 1 to the power, that becomes negative 2, divide by the new power, negative 2, and then differentiate x minus 3, the inner function, and you get 1 plus a constant. So this becomes y is equal to 4 over negative 2, that gives us negative 2, and that's x minus 3 to the negative 2 plus our constant of integration. Now we were given the set of points, the set of coordinates to use, that's 4, 5. So substitute y with 5, and then x with 4 minus 3 to the power negative 2 plus c. 5 is equal to, punch that into your calculator, negative 2 times 4 minus 3 to the negative 2, you get negative 2 plus c. So c is equal to 7, and therefore the equation of the curve, therefore y is equal to negative 2 x minus 3 to the negative 2 plus 7, And this is the final answer. The function f is defined by f of x is equal to 4x plus 2 to the negative 2, for x is greater than negative half. Find the integral of f of x with respect to x from 1 to infinity. Okay, so we're integrating from 1 to infinity, and that's 4x plus 2 to the negative 2 with respect to x. Okay, so if we integrate that, this is 4x plus 2. Add 1 to the power, you get negative 1. Divide by this new power, negative 1. And then differentiate 4x plus 2. You get 4. And our limits are 1 and infinity. So this simplifies to give negative, that's 1 over 4, 4x plus 2 to the negative 1, and then our limits 1 and infinity. So I'm going to take the negative a quarter outside our square brackets, so that this becomes 4x plus 2 to the negative 1. That's from 1 to infinity. And then let's make our power positive inside that bracket, so that this is 1 over 4x plus 2 from 1 going up to infinity. Now let's substitute in our limits. So that becomes 1 over 4 infinity plus 2 minus, let's substitute in our lower limit, 1 over 4 times 1 plus 2. Let's close the brackets. So this is negative 1 over 4. And then we have 1 over 4 infinity plus 2. How do we simplify that? So the idea that we're going to use is that 1 over infinity is equal to 0. You should be familiar with this concept. However, it's a very rare concept, so it rarely comes up. The idea is that when you divide 1 by a very large number, you can try it on your calculator. For example, say 1 over 10,000. You probably get something very small. On my calculator, I'm getting 0.0001. So as the number on the denominator gets very large, it means that our answer will approach 0. So when we are dividing by infinity, the number becomes very small, such that we approximate it to be 0. So 1 over infinity is 0. And so here what we end up with is 0 minus, let's evaluate our lower limit. That's 1 over 4 times 1 plus 2. We get 1 over 6. 1 over 6. So this becomes, let's scroll up. You end up with negative 1 over 4 times negative 1 over 6, which gives us 1 over 24. And therefore, 1 over 24 would be the final answer. The diagram shows the curve with equation y equals 10x to the half minus 5 over 2x to the 3 over 2, for x is greater than 0. The curve meets the x-axis at the points 0, 0, and 4, 0. Find the area of the shaded region. Okay, so we are integrating our function from 0 to 4 with respect to x. So that's 10x to the half minus 5 over 2x to the 3 over 2. So to get the area under the graph, we integrate. So if we integrate 10x to the half, so add 1 to the power, you get 3 over 2. Let's divide by a new power, 3 over 2. That's the same as multiplying by 2 over 3. And then we've got negative 5 over 2x to the 3 over 2. So add 1 to the power. That becomes 5 over 2. And then divide by this new power. That's the same as dividing by 5 over 2 is the same as multiplying by 2 over 5. And our limits are 0 and 4. Now let's simplify this. We've got 2/3 times 10. So that's 20 over 3 x to the 3 over 2 minus 5 over 2 times 2 over 5. You get negative x to the 5 over 2, and our limits are from 0 to 4. Let's substitute in our limits. That's 20 over 3, substitute x with 4 to the power 3 over 2, minus 4 to the power 5 over 2. Now if you substitute 0, we just end up with 0, so I'll just write a 0 over there. And now let's simplify that. Punch that into your calculator. 20 over 3 times 4 to the 3 over 2 minus 4 to the 5 over 2, and that gives us 64 over 3, and this is the area under the curve. This is the area of the shaded region. The diagram shows the curve with equation x is equal to y squared plus 1. The points A, 5, 2, and B, 2, negative 1 lie on the curve. It is given that the equation of the line AB is y is equal to x minus 3. Okay, so this line is equation y is equal to x minus 3. Find the volume of revolution when the region between the curve and the line AB is rotated through 360 degrees about the y-axis. So we want the volume when the shaded region is rotated about the y-axis. So the formula that we use for volume of revolution about the y-axis is the integral of pi x squared with respect to y. So since we want the region, the shaded region, it means we want the volume that will be generated by this line minus the volume generated by our curve. So we can write an expression to say that the volume that we want will be equal to volume generated by line minus volume generated by curve. And we're going to use the same formula, the integral of pi x squared with respect to y. So the equation of a line is y is equal to x minus 3, and then with the equation of our curve being x is equal to y squared plus 1. So you notice that we have x squared in our formula, so that means we have to make x squared the subject of the formula for both equations. So let's start with the line. This becomes x is equal to y plus 3. If you square both sides, that's x squared is equal to y plus 3 squared. Let's just expand that. X squared is equal to y squared plus 6y plus 9. Let's make x squared the subject of the formula here as well. So that's y squared plus 1 squared. And if we expand, that becomes y to the power 4 plus that's 2y squared plus 1. Okay, and now we can use the formula and say the integral. We're going to bring the pi outside, so it's pi the integral of x squared. In this case, x squared is what? Y squared plus 6y plus 9. This is with respect to y. And our limits will be the y coordinates. Since it's respect to y, we're using the y coordinates of our points of intersection A and B. So that's from -1 to 2. So we're integrating from -1 to 2. And then we're doing the same for the curve, pi the integral of x squared. In this case, that's y to the 4 plus 2y squared plus 1 with respect to y. That's from -1 to 2. Notice how our limits are the same, so we can combine the integral to become pi, the integral from -1 to 2 of y squared plus 6y plus 9. Then you subtract this from that, that's y to the 4 plus 2y squared plus 1 with respect to y. You could also just integrate them separately, but it's more efficient if you do it in this manner. So that's pi the integral from -1 to 2 of y squared plus 6y plus 9. Let's expand that. That's -y to the 4 negative 2y squared, negative 1 with respect to y. Simplify like terms. So we end up with pi, the integral from negative 1 to 2 of negative y to the 4, and then y squared minus 2y squared gives us negative y squared, and we have plus 6y over here, and then 9 minus 1, which gives us a positive 8, and this is with respect to y. Now we can integrate. So if you integrate negative y to the 4, you add 1 to the power, that's 5, and you divide by 5. Then negative y squared, you add 1 to the power, that's 3, divide by 3. Then 6y, you add 1 to the power, that's 2, divide by 2. Then 8 becomes 8y, and we have a pi outside, and then we're going from negative 1 to 2. Now let's simplify this before we substitute our limits. That's negative y to the 5 over 5 minus y cubed over 3 plus 6 over 2, that's 3y squared plus 8y, and this is from negative 1 to 2. Now let's substitute in our limits, so that becomes pi negative, substitute y with 2, so that's minus 2 cubed over 3 plus 3 times 2 squared plus 8 times 2, and there should be a big bracket over here, minus our lower limit, that's negative 1 to the 5 over 5 minus negative 1 to the 3 over 3 plus 3 times negative 1 squared plus 8 times negative 1. Let's close that. Now let's punch the calculation for the upper limit into our calculator. So that's negative 2 to the 5 over 5 minus 2 to the 3 over 3 plus 3 times 2 squared plus 8 times 2, and that gives us 284 over 15. So 284 over 15. Now let's substitute in the lower limit. So that's negative 1 to the 5 over 5 minus negative 1 to the 3 over 3 plus 3 times negative 1 squared plus 8 times negative 1, and that gives us negative 67 over 15. Now let's simplify this. That's 284 over 15 plus 67 over 15, and you get 117 over 5. So 117 over 5 pi, and this is our volume of revolution. So that's it for the integration video. You can now go on to work on the topical question. Bye-bye.